how the replica path or the reference wet line is designed. Now we come to another part which which will then lead us to non-volatile memories also, which is the charge pump. What is a charge pump? What is a charge pump? No one has heard about charge pump earlier? Okay. So charge pump is a circuit which increases voltage from the levels that are available. So I have a voltage available which is 1 volt. I can generate 2 volt, 3 volt, 10 volt output by using 1 volt. Similarly, I have something available as ground and I could generate negative voltage on the ground. That is also a charge pump. Now, those of you who are working on the negative word line, negative bit line right driver, can you sense something? What could be a charge pump? What could a charge pump look like?
Some circuit with capacitor.
There is a capacitor which stores charge, and then that charge is pumped onto another capacitor, due to which the voltage between the plates of the other capacitor rises very much. The extra charge has pumped up the voltage. So this is how it would appear. So there is a capacitor, there is another capacitor, and it is the interplay of these two capacitors that leads to, or that results in, a V out which is higher than what was V in. How do we do that? So we divide the operation into multiple phases. The first phase is, let us say, charge phase. So what is done? In charge phase, S3 and S2 are closed, appear to be like resistances. So what happens? There is a charge that flows from V in until this side, and the charge from the other side of this capacitor goes to 0. So capacitor CS is holding some charge onto it. Some voltage would appear. What voltage? That would be equivalent to Vn, or a little drop around it, but finally stabilizing at Vn. Okay? Then we move into the next phase, which is about charging. So then we move to the next step, which is about charging the C out. So अभी तक हमने क्या देखा? Charge phase में Vn एक तरफ लगा and this kind of a path was created. In the next phase, what we do is we discharge. What does discharge mean? Now I close these two resistances, these two switches, and I open the ones that were closed earlier. All of a sudden, what happens? This plate, which earlier had a 0 on it, now at once has a Vn on it. What does that mean? Because we know that this side has much more charged, was more charged. So this plus Vn goes to 2Vn. Okay? And this Vn or this CF, this node is connected to V out. So we can actually say V out is approximately equal to twice Vn. Are you able to see this? What have I done? I first stored charge onto this particular capacitor, and then I changed the charge of the voltage on the other side, other plate of the capacitor, so that this charge could now be pumped onto the output capacitance or the output load. Is it clear? This is the new circuit, the red one. let us look at it in terms of a time series. So that was just one step में आपको लगा कि सीधा VDD 2 VDD आ गया. Doesn't really happen like that. In reality, when the charge pump starts to operate, then the voltage VGG over here, which we say is the V output voltage, would see this kind of increase, a stepped increase, and then almost becoming stable. The black curve. How is it operating? Who can explain? सब कुछ सामने है. चलो, let us say ring oscillator gave a output 1. So what happened? The C was initially 0, it will go to 1. Until it has gone to 1, this transistor is off. Huh? And D would go to 0, from 1 to 0. So this transistor is off. So this side of this node holds the earlier voltage only, earlier charge only, and the other side has discharged to 0. What happens? There could be an impact around the diode. Okay? Otherwise, you would transfer some charge to this particular capacitor VG, and then you would change the voltage of the other plate so that you have 2 VG available to you. 2 VG will not come instantaneously, it will come over time. Is it okay? Are you able to see the functionality? Is it clear? Hello? Any questions? Friends, is it clear?
So if we add more inverters, the charging phase will increase. So it will quickly go to that, right?
Yes. If we add more inverters, charging phase would increase. We could probably have a slightly higher rise per cycle. We could probably rise a little higher per cycle. But the thing is that you want to be fast, so higher per cycle, but that would take a little longer. So I will have more number of cycles that I would need. No, fewer number of cycles, but the cycles are larger in themselves. Over here, we have used fewer inverters, so every cycle is short, but I may need more cycles to go to the desired voltage level. Okay? So what is happening is, I say that there is this VGG. So this is the equivalent circuit there. There is a capacitor CS, this one, and this capacitor shares the load or pumps the charge onto the load capacitor, which is much larger. And overall, the timing improves. Is this okay?
Yes, sir.
Great. So again, we will come to approximately 2 V high after some time. So we will stop here. We will start with non-volatile memories in the last class. If there are any pending questions regarding DRAMs, you can ask that. If there are any questions related to projects, we can discuss those also.
Sir, in the last class, TRC, which was given 110 milliseconds. which carries precharge plus TRAS.
Hmm.
We saw that precharge is only about equalizing the 2-bit line. So I think
Hmm.
it's very, it will take very less time. So RAS was itself 30 millisecond, but we are 70, 80 millisecond we are taking as a precharge here, right?
So, have you tried equalizing two signals,
Mm.
bitline and bitline bar, when you are precharging them in the SRAM itself? Let us say, forget about the DRAM. In the SRAM, there is a bitline and bitline bar, and you want to, what do you say? And you want to equalize them. You put an equalizer there. How long does it take, do you think?
Don't know, but I think the bit line C is very high. That's why is it taking too much time?
Yeah, that is definitely there. But even equalization from let us say VDD by 2 minus 40 millivolts and VDD by 2 plus 40 millivolts to VDD by 2, almost VDD by 2 on both the bit lines, means that you are transferring information across a pass gate. So this is VDD by 2 minus 40 millivolts and VDD by 2 plus 40 millivolts. So what happens? You are you are transferring charge at a VDS of approximately 80 millivolts. This is still fine VDS. As this becomes 30 and 30, it goes to 60. As it becomes this VDS goes lower, the total time it would take to charge would increase because VDS is low, so the current that is flowing has reduced. Is that okay?
Yes, sir. It's experimentally, if we see that will be more clear. Like if the difference is small, that will take lot of time to equalize.
Yes. है ना? Anything else?
Sir, in the early read operation, in the last lecture,
Mhm.
we saw that CAS will come later, but there was a jump because the output was high. So how that will be distinguished from junk, data out and junk? Like output was high, no? So,
So junk you don't bother about. You simply latch output only after T access.
but memory is giving output based on o output access time, right?
Yeah. Memory could be giving output wherever. But when do you latch the memory output? That is what is important, na? Memory output will be latched somewhere, either in the next stage of flip-flop, somewhere it would be latched. At the system level also, you will need to latch memory output, na, somewhere.
Yes, sir.
So you do that after access time. Then there is no problem of whether there was junk before the access time or not. Is it clear?
Controller has to work like जब CS आए तभी output ले.
हम्म दोबारा से पूछो. पूछ रहे थे, बता रहे थे, मेरे को तुम्हारी टोनालिटी से समझ में नहीं आया.
OE जो कंट्रोलर होगा that will look for OEL, right? The chip output chip enables वाला signal कि अगर
Yes,
वो on हो तो it should take the data from memory,
yes,
right?
yes.
But वो टाइम पर CAS on नहीं है. CAS is a internal signal of memory.
हाँ,
तो
that is
जैसे ही
okay.
OEL आया तो memory controller will start taking the output जो भी दे रहा है वो, right?
Yeah, so you will
वो
bring,
टाइम पर जंक आ गया ना
you will
सर.
either bring OEN after the output is stable, let us say, which could be called as late read, or if OEN was all low already, then there would be some junk on the output, but you will latch the output only later. ON is only output being driven to the bus. This is the output bus. Output bus would also latch it somewhere. That latching should happen after the total access time has elapsed. Is that okay?
Yes, sir.